basically. So containerization is it's simply a deployment model. Okay, so how you can deploy your application, and also it's a way to package up your application in such a way that no matter on which platform or which environment you will run your application, you will get the full working version of the application. So you don't have to worry about any dependencies or any components needed to run that application. So what I mean by that is it could be your application code, it could be your binaries, the libraries, the dependencies, the configuration files. So anything you need for the application to run, everything will be available within that package, right? So now I can take this package and deploy it on any platform, any machine I want, and that package will make sure the application has everything to run without any issues. Okay, so we looked at that. We looked at the benefits, and we also looked at the various tools that are available as part of your containerization, right? So we have your Docker, we have Kubernetes, we have ECS in AWS, EKS, which is your Elastic Container Service, and then we have your OpenShift. So likewise, we have different tools that are available which can be used to containerize your applications, right? So we'll continue from there. So we are going to look at your Docker. So we will be covering two tools as part of your containerization. So first we are going to look at your Docker, and then post that we will also look at your Kubernetes. So as of now in the market, Docker and Kubernetes, they are very high in demand. So I would definitely suggest you to spend more time on this. Learn Docker and Kubernetes. It's really important. Many companies are adopting containerizations to run their applications. All right, so this is something that you will definitely need to spend time on, right? So just give me one moment, and let me share my screen. Yeah, so I'm sharing my screen. Let me know if you're not able to see that. And we are going to start off with Docker.
Ravi, like one question. So if
Yeah.
right now, like, all the companies are using cloud technology, right? So like,
Mhm.
like AWS and Azure and all. So most of the companies should be using Amazon ECS and EKS instead of like Docker and Kubernetes. So why do we use Docker over ECS or EKS?
So when see, yeah, I mean, many companies are using cloud like AWS, let's say in that case. Now, before before even before you can start working with Docker, you need to build your images, all right, or ECS or EKS, any containerization tool. Before you start working with that, you will need to build the images, all right, the package. Now, for that, you will need to make use of your Docker. Okay, so Docker, we use it to build your images, that package that I've been talking about. We build that by making use of your Docker. Okay, so basically the
Okay.
base, before you can start off working with ECS or EKS, you need to have that package. And for that purpose, we make use of your Docker first.
Okay.
Any other questions, anyone?
No, sir. It's
Okay.
No.
So cool. So introduction. So we, as of now, first we are going to look at your Docker, and also, the base. To work with your ECS or EKS, they are same. Okay. So like how if you know Docker, you can easily work with your ECS. If not, what happens is you need to completely learn your ECS service, how it works, how to run the containers, what are containers. So those basic concepts you will need to learn again. Now, if you already know Docker, you can easily get started with your ECS service. And if you know Kubernetes, you can easily get started with your EKS service. Okay. All right. So we are going to look at your introduction to Docker first. So Docker This was developed by the companies with the same name, Docker Inc. That's the company which developed it. This is an open source container orchestration tool. So this is completely open source. Uh, uh, you have the free version under this, so you can play with this, you can work around with this. This was first started in 2013. Okay, so that's when this was released to the public, and this is written in the Go programming language, right? So most of the containerization tools you will see they're developed in the Go programming language. Okay, so Docker is a platform as a service. So this falls under your PaaS, platform as a service, and you can use this. This follows your OS level virtualization. So all the isolation of your resources, your applications, and everything, it happens at the OS level, and this helps you to deliver your software in packages, which we call it as your containers. Right. So these applications or whatever the package that you're going to create, we call them as your um, containers, right? So containers, now these are isolated from each other. So containers are nothing but your applications. Okay, so whenever we talk about, hey, can you containerize? That's nothing but we are talking about containerizing an application. Now these containers, these are isolated from each other, meaning one container cannot talk to another container by default. And each of these container will have their own software, their own libraries, the configuration files. And also if you want, they can communicate with each other through well-defined channels. So if you want these containers to talk to each other, you can do that also. That is also possible, right? Now Docker is basically a container engine which uses the Linux kernel features like namespaces and control groups to create containers on top of the operating system. So, this is an OS level virtualization. So, it works on the same operating system and automates application deployment on the container. So, Docker is a tool that is designed to make it easier for us to create, deploy, and run the applications by making use of your containers. So, these containers, it's a generic concept. Okay, Docker is a tool which can help us to work with your containers. So Docker containers allows a developer to package up an application with everything that is needed for that application to run, such as your libraries, the dependencies, the configuration files, everything. We'll be packaging it up and then we deploy it as one single package, right? So this is how it works. So using Docker, we create an image. Now this image is nothing but your package. So this contains all the instructions for the application. So how you want to run that application, what are the components that are needed to run that application, like your binaries, libraries, dependencies, everything will be available in this image. Now when I run this image, I get a container. Now container, it's nothing but your running version. Okay, so that's a running instance of the image. So you can think of it as you have your AMI, right? Now from the AMI, we launch an EC2 instance. So this AMI will be your image and container will be your EC2 instance. Does that make sense?
Yes.
Okay. And then from here, we get the containerized application, which the end users can start accessing it. So once again, the flow would be we use Docker. Using that Docker, we build an image, and then using that image, we create our container. So we can create any number of containers you want, and these containers they give us the application, the containerized applications, basically. Okay. Now you may have a question as to what's the difference between virtual machines and your Docker containerizations, right? So the first thing that you need to understand is Docker containers are not virtual machines. So these are two different things. Okay, these are completely two different things. Your Docker containers and your virtual machines. So we are going to understand the difference between them. So let's first understand your virtual machines. So virtual machines, you have your infrastructure. So infrastructure is like your hardware. All right. So you have your hardware. Now, on top of that hardware, you have your host operating system. Let's call it as your Windows operating system. Okay. So I have my the hardware. On top of the hardware, I create my host. I'll install, let's say, an operating system. And on top of that, I will install an hypervisor. Now, what's an hypervisor? Hypervisor is a tool like your VMware ESXi or Oracle VirtualBox or any of those tools. We install that hypervisor. And then using this hypervisor, we start creating your virtual machines. So we can have any number of virtual machines, and each of these virtual machines will have its own binaries and libraries, and we'll deploy the application. Likewise, this will have its own binaries and libraries and the application. Likewise, this will have its own binaries, libraries, and the application. So this is your hardware level virtualization. So whatever the host infrastructure that we have, we divide that. So let's say you have 8 GB. So 2 GB will be allocated to this operating system, 2 GB will be allocated to this operating system, and then 2 GB will be allocated to this operating system. And the remaining 2 GB will be available with the host operating system. That's your virtual machines. That's how it works. Does this make sense?
Yes, Ravi.
Yes, sir.
Now, it all begins with some type of infrastructure like your hardware. All right. You will have the hardware. On top of that, you will be running your operating system. Okay. Any operating system you want will be running. Then we have a thing called hypervisor. The next layer in this are your guest operating systems. Then on top of that, each guest operating system needs to have its own copy of various binaries and libraries. And then finally, we have the application. That's how your virtual machines work. Now, how does your containerizations work? Now, under this also, you have your infrastructure, you have the hardware, you'll have the host operating system. After this, we have something known as your Docker daemon. So we don't make use of your hypervisors over here. Rather, we use your containerization technology, which is OS level virtualization. So at the OS level itself, we'll be doing it. So we install a tool, containerization tool, and then using that, we create your containers. So we're not creating any virtual machines here. On the same machine, we are creating your isolated containers. So app one will have its own container, app two will have its own container, app three will have its own container, and it will start utilizing the resources of your host operating system. That's how your containers work. Docker container also runs on some type of infrastructure. Then we have the host operating system. Then we have the daemon that replaces the hypervisor. So here we don't have the hypervisor. Next, we have the binaries and libraries. Then finally, we have the applications running on the host operating system as a container. Does that make sense?
Yes, Ravi.
Yes, sir.
Cool. So containers versus virtual machines. Containers, these are lightweight. Virtual machines, they are very heavyweight. So what I mean by that is, if you look at your virtual machines, they will always be around 1.8 GB, 2 GB, 2.5 GB in size. All right. But your containers are very lightweight. They will be only in few MBs only. Right. Then containers gives you native performance. Virtual machines, they have a very limited performance. So they are limited to that operating system only. Okay. Then containers, all containers share the host operating system. So, it runs on the same operating system. Virtual machines, each of the VM runs in its own operating system. So, each of these virtual machine has its own guest operating system, and you'll be, running these applications in its own virtual machine. So containers, this follows your OS level virtualization, whereas your virtual machines, this follows your hardware level virtualization. So your containers, they take few milliseconds to start up. Virtual machines, they take few minutes to start up. So also the start time is long. Then containers requires less memory space. Virtual machines, you will need to allocate the memory. Without that, you won't be able to work with it. And then finally, containers, these are your process level isolation, whereas your virtual machines, these are fully isolated. Questions?
No, Ravi.
No, sir.
Okay. All right, so then let's understand your Docker architecture, how your Docker works. All right, so Docker it follows your client server architecture. So here we'll have two components. Okay, we'll have the client, and then we will have the server. Okay, so we'll have both the things. So it consists of your client, your server, and also a REST API. So we have three things. Okay, so we have the client, we have the server, and also the REST API. So the Docker client is what we use to do all the interaction. Now, if you want to create an image, run a container, anything you want to do, we do that by making use of your Docker client. Right? And then we have the Docker server. So Docker server is the one that actually does all the work for us. So Docker client can be used to give all the instructions. These instructions will be sent to the Docker server, and then Docker server will execute those instructions for us. Now the communication between this Docker client and the Docker server is done by your REST API. So this REST API helps your Docker client and Docker server to talk to each other. So when I run any command, like, so let's say, hey, start a new container, these instructions will go to the REST API, and then REST API will send it to the Docker server to execute those instructions. Okay, so we'll have three components over here. So this is how it works. Install your Docker on your local machine. When we install the Docker on your local machine, we'll get two things. Okay, so we have the local machine and we have the online host. Okay, so I'll come to the online host in some time. So on the local machine, when we install your Docker, we'll get two things. We get the Docker client as well as the Docker daemon. So Docker daemon here is nothing but your server, the Docker server. All right. Now, we use the Docker client to give all the instructions. Yes, online host, I'll come to that in a bit. Okay. So, give me one moment. Sorry, give me 1 minute. Need to find something. Okay. So we have the local machine and we have the online host. Now, online host over here will be used to. So this is going to be your repository. Now, like how we have your GitHub, which acts as your central repository, we have your Docker registry, okay, which acts as a central repository. Now, at any point, if you want to share your images with other people, all right, you can push that to a repository, which is your Docker registry in this case, so that others can also use it. Like, let's say I have built an image, I want to share that with you. For that, I make use of your Docker registry. So it's a central repository for us to store your images. Okay. So in the Docker registry, we can have all sort of images like your Ubuntu, Python, Jenkins, CentOS, anything you want will be available. And then Docker daemon is the one that will help us to manage the containers and the images. So what happens is, whenever we run any command, so let's have the Docker client. Now, using this Docker client, let's say I will run a command called docker build, or let's say docker pull, or let's say docker run. I will, have any of these commands. When I run these instructions, what happens is these instructions will be sent to the Docker daemon via the REST API. So Docker client, and I have the Docker server. So whenever I run the instructions over here, these instructions will be sent to the Docker server via the REST API. Now, once the instructions are sent to Docker daemon will first check in the local machine itself. Like, for example, let's say I'm trying to pull an image. Pull is nothing but downloading an image. So the Docker daemon will first check on the local machine itself, whether the image is available or not. So let's say I'm trying to do a docker pull Ubuntu. What Docker daemon will do is Docker daemon will check on my local machine whether this image is available or not. If the machine is available, if the image is available, it will simply create that container for us, right? However, if the image is not available, what will happen is the Docker daemon will go to the Docker registry, search for that image, download that image to my local machine, and then run the container. That's the flow. So We use the Docker client to give the instructions. These instructions will be sent to the Docker daemon. Docker daemon will first check on the local machine itself whether the image is available or not. If the image is available, it will simply reuse that image. If the image is not available, it will go to the Docker registry, search for the image, download that image, and then run the container. That's how it works. Questions?
No, Ravi. Understood.
No, sir.
Okay.
No, Ravi. No, sir.
So let's look at your different components that we have in Docker. Docker consists of many components that makes up for the Docker. Okay, so we have the Docker daemon. So Docker daemon is simply a Docker server. Then we have the Docker client. So Docker client is what we use to give all the instructions. And then we have the Docker images, we have Docker containers, Docker registry, Docker services. So likewise, we have different components that makes up for your containers, the Docker. Okay, so let's look at each of these one by one. So the Docker daemon, that's your server. Okay, so this is the server. So Docker daemon listens for the API requests, and this is the main component which manages all of our objects, such as your images, your containers, your networks, your volumes. Everything is managed by your Docker daemon itself. So daemon can also communicate with other daemons to manage Docker services. So that's your server. Okay. So at any point, if you want to manage, like create a container, Docker daemon is doing it for you. Create an image, Docker daemon is doing it for us. So everything will be done by the Docker daemon. Then, so here, that's what it is doing. So this Docker daemon is the one that manages everything for us, the images, the containers, and all. Then we have the Docker client. The Docker client is what we use to interact with the Docker. So that's a CLI tool which helps us to interact with the Docker, basically. So the Docker client, that's the primary way that many Docker users can interact with the Docker. When you use commands such as docker run, the client sends these document commands to Docker D, which is your daemon, which carries them out. So the Docker command uses the Docker API. The Docker client can communicate with more than one daemon. So this is what we use to issue all the commands. So any commands you want to execute, we pass it by using the Docker client. Questions?
No, Ravi.
Okay. Then we have your Docker images. Now, Docker image is simply the package. Okay, so that's a read-only template with all the instructions that are needed for creating your container. So often, an image is based on another image with some additional customization. For example, you may build an image which is based on the Ubuntu image, but installs the Apache web server and your application, as well as the configuration details needed to make your application run. So your Docker images, you always make use of a base image. Okay, and then using that base image, we create your customized image. So I'll be showing you how you can create your images and all that. But Docker image is simply going to be your template. It's a read-only template, which has all the instructions basically. Okay, as to what type of container you want to create, then what data you want to store. So all those instructions we are providing it by making use of your Docker images. Okay, then we have the Docker container. So this Docker container is a running version of your image. Okay, so again, like I said, you can think of your Docker images as your AMIs, Docker containers as your EC2 instances. So a container is a runnable instance of an image. You can create, start, stop, move, or delete a container using the Docker API or CLI. You can connect a container to one or more networks, attach storage to it, or even create a new image based on its current state. So simply running container to running an image into a container, that's simply Docker containers. Questions?
No,
No,
Ravi.
sir.
Okay. Then we have the Docker registry. Docker registries, at any point, if you want to share your images, so let's say you have built a custom image, and if you want to share that image with other users, we can store we can store those images on your Docker registry. So Docker registry stores your Docker images, Docker Hub, and Docker Cloud. These are public registries that anyone can use. So we have these tools called Docker Hub or Docker Cloud that we can use to store our images. So, and Docker is configured to look for images on Docker Hub by default. You can even run your own private registry. When you use the Docker pull or the Docker run commands, the required images are pulled from your configured registry. When you use the Docker push command, your image is pushed to your configured registry. So, this is same as downloading an image, pushing an image, but we have a central repository for that, which is a Docker registry. And then finally, we have your Docker services. Docker services can be used when you want to scale your containers. Like, you want to run multiple containers at the same time. We can make use of your Docker services for that. So services allow you to scale containers across multiple daemons, which all work together as a swarm with multiple managers and workers. So under this, basically, if you want to create a cluster, like multiple machines, and you want to work with those multiple machines, we make use of your Docker services. We'll be talking more on this later on. So each member of a swarm is a Docker daemon, and the daemons all communicate using the Docker API. A service allows you to define the desired state, such as the number of replicas of the service that must be available at any given time. By default, the service is load balanced across all worker nodes. So essentially, if you want to have your containers run across multiple machines, we can make use of your Docker services for that. So these are all the components that we have when we talk about your Docker. Any questions?
No, Ravi.
No, sir.
Okay. The next thing we are going to look at is a Docker installation. Now, Docker can be installed anywhere you want, Linux, Windows, Mac OS, anywhere you want, you can install it. In my case, I'm going to do this on a Linux machine, and I'm going to use an EC2 instance for this. But you're free to use whatever you want. Like, let's say you want to do it on your Windows machine, you can do it. However, it has certain system requirements that you'll need to satisfy. Come on. Okay. My account looks like my account is suspended because I did not make the payment. Okay. Fine. I will grab that later. So here you should find the instructions. So download Docker desktop for Linux, Docker desktop for Mac, Docker desktop for Windows, and here also you have the option. So 1, 2, and so you can install this anywhere you want. We will be looking at your Ubuntu, and here it will give you the requirements. So OS requirement, and then the commands, how you can install this. Everything will be available. Now, if you're interested to do this on a Windows machine, like I said, you're free to do that. Let me show over here. So if you go to this, sorry, not Mac OS, but if you go over here, so you have two options. You can go with this WSL2 backend, that's one option, or Hyper-V backend and Windows container. So these are two options that are available. So this is also a way to run virtual machines. So you need to install this WSL version, and once you have that, here you have the steps. So you need to just download the installer. Once you have the installer, just run it. So here, Docker desktop for Windows. So you can install this anywhere you want, but I would say stick to the Linux. It's easier, much easier to work with. I'll show tomorrow this one because I need to fix my account, AWS account. But you can install this anywhere you want. So if you're on Amazon Linux AMI to start working with your Docker, you need to install Docker on your machine. So you can run this yum install docker. That will install Docker on your Amazon Linux AMI. Okay. If you're on Red Hat, you can use the same command. And if you're on Ubuntu, you can use apt update and then apt install. That will install on your Ubuntu machine. So I'll show this tomorrow. Now that's one way. Now what this will do is this will always install the latest version for us. But if you want to install a specific version, maybe a little older version, you can make use of the binaries for that. So you can follow this URL, and in this URL, right, you'll have all the binaries. You can also go to this one where you have the binaries. So here you can choose which version. So in my case this will be this, and here these are all the versions that are available. So you can see there's the oldest version we have, and at the bottom here that's the latest version you have. So by default this will install the, if you run this apt install, this will install this version 24. But if you want any other version, the older version, you can directly download the binaries and you just have to follow these instructions. That's all. So you can download those binary files, unzip it, move it to your bin folder, and then start the daemon. That's it. So there are different ways based on your requirement, based on your use case. You can choose how you want to install Docker on your machine. So again, I'll be showing this tomorrow. And again, if you want to install this on your Windows machine, you can do that also. But yeah, pretty much that's all. Questions?
No, Ravi.
No, sir.
Okay. Yeah, I need Docker for this. Okay. I need Docker. Okay. Just give me one moment. I'll stop the recording for a moment.